Hey guys, welcome back to another video. This video is part 2 of my first video talking about continuity. This video is just going to be focusing on some practice problems. So let's begin. Okay, so we have this first limit here, and it's asking us for the limit of -6 over x minus 7 as we approach 7 from the left. So let's see this graphically. So we have 7 over here, and we have -6. So this is basically similar to the function of 1 over x, but it's reflected and you shift it to the right 7 units. So you should have something like this, right? But if you don't know function behavior, this might be a bit tricky. So what we can do is do sign analysis near 7. So we have 7, and we're trying to see what happens when we approach it from the left. So imagine we have like 6.9999999. So let's plug that in. F of 6.9999 is equal to -6 over 6.99999 minus 7, and that's -6 over -0.0001, and that's like roughly like 6,000 or 10,000. I mean 60,000. And so we get the limit as we approach 7 from the left is equal to positive infinity because we reached such a big number. Okay, so for the second question, it's asking us for the limit of 1 minus cosine x times sine 4x over 4x as we approach 0. So as you can see here, we have a trigonometric property over here. So we can factor that out. So we can say we have the limit of 1 minus cosine x times the limit as we approach 0 of sine 4x over 4x. And this is simplified to 1 minus cosine 0 times 1, and 1 minus cosine 0. Cosine 0 is equal to 1, so we get that our final answer is equal to 0. Okay, so for our third question, it's asking us for the step function. So if you recall, we have the limit as we approach n from the left of the step function. We have a step function. We have that is equal to n minus 1, and if we have the limit as we approach n from the left of the step function, then we have n. So as you can see, we're approaching 5 from the left. So we're just going to plug in -5 times n minus 1, so -5 minus 1, so that's -6 minus 4. So that's equal to 30 minus 4, also known as 26. Okay, so this question is asking us for a and b so that f of x is continuous for all of x. So we need to find some a and b so that each part of the graph is connected to each other. So let's see. So since we want it to be equal to each other, we want like f of c to be equal to each other. So we have so let's plug in 1 for over here. So we have a times 1 squared, which is just a plus 3, and let's set that equal to 2x plus b when x equals 1. So this is equal to 2 plus b. Okay, so now let's find the value for 4. So we have 2 times 4, which is 8, plus b, and that's equal to x squared minus 1 when x equals 4. So that's 16 minus 1, or 15. So if we were to isolate for b, we have b equals 7, and we have a plus 3 equals 2 plus b, but b is equal to 7, so we get a plus 3 is equal to 9. We subtract 3, we get that a equals 6, and that b equals 7. So a equals 6, and b equals 7. So this works because when they're connected, f of c from over here, or what it gets very close to, is equal to f of c of over here. So they're connected, they're connected. So that's the reason why that works. Okay, so this is for our last problem. We're trying to find the vertical asymptotes and the removable discontinuities of the graph. So as you can see, this is likely a factorable function. So let's set this equal to x plus 6. Let's see, 42. What factors of 42 out of 13? 6 and 7. So we can put x plus 6 times x plus 7 as our factors. As you can see here, that these two cancel out, which means that there's a removable discontinuity at x minus 6. Because if you were to put x equal to -6, it would be 0, and that would be undefined. So if we were to factor it out, then it would the function would still sort of exist there, but it would approach that value. So like -6 over here, it would approach right there. And so when we have the function reduced, we have 1 over x plus 7. So we have an asymptote when the denominator is equal to 0, but the numerator is equal to 1. So x is just equal to -7. So we have x is equal to -7 for the vertical asymptote, and the removable discontinuity is at x equals -6. But sometimes it asks you for the point. So what we're going to do is we're going to plug it into the new function. So we have 1 over x plus 7, or 1 over -6 plus 7, which is just -1. Because you put 1 divided by -1, and that's just -1. So we have the removable discontinuity at x equals -6, or the point -6, -1, and we have a vertical asymptote at x equals -7. Thank you for watching this video, and I hope you enjoyed and learned something new.